Okay, guys. So let's start. So today's topic is SSL. Okay. SSL means what? That is all about secure socket layer. Okay. So this is like a kind of one of the sort of protocols like IPsec. Okay. So guys, if I'll talk about an IPsec, in IPsec we discussed that it's like a kind of sort of the protocol. So in IPsec, what are the protocols we have? So in that we have option about IK, IKV1, IKV2, and after that there was ESP, AH kind of concepts, right? So same in SSL also we have a different kind of protocols. So that we will discuss. But before this, I'll just start with it just from its history, how exactly the SSL started. So first of all, actually, ISL started in 1980s. Okay. So that time, they developed not SSL exactly. First of all, I'll talk about HTTP. Okay. So if I'll talk about HTTP, so first of all, they have started HTTP in 1980s. Actually, they started with in 1980s. So there was a company that time, and that was known as ITEF, Engineering Task Force is there. This is something international and engineering task force something is there. So this is the one of the organization just who started STTP in 1980s, and that time there what was the purpose for STTP? The main purpose for STTP was so like communication between any client and a server. That's it. That was overall concept for that. Okay, just as client to server communication via browsers and all. So, but that time STTP, STTP was not secure. Okay, so this was just a normal protocol. So after that, later after this, so in 19s then, so it started in 1980s. So after that, in 1994, I think. Okay, 1 second. Not here. I think I'll just come back here only. Here only I'll set. So what happened then? After that, there was STT. First of all, in 1980s they started. Then STTP 1980s actually. So first of all, it was 1980s. Okay. After that, from here, then again there was a first of all, who started with STTP, ITF. So, but after that in 1990s, so there was a one more organization came, that was Netscape. Okay, so there was a organization Netscape, and along with that, IETF. So both the companies, okay, they have started working on the advanced version of HTTP with the secure concept and all. So that time, Netscape first time they developed a separate concept about SSL. Okay, they came with SSL in that was approximately 1994. Okay, and IETF then came with the concept about SHTTP. That was SHTTP. So this concept was about secure HTTP. But because of some technicalities from of technical issues and all, this project got failed. Okay, so they have not they never launched HTTP, but in the starting they came with SSL. Okay, and in the starting SSL version 1, they launched with SSL version 1, and this was the concept about your like for the testing purpose. So this was the actually like they used as a in headquarter, and after that this was their branch offices. So in their corporate only in their organization itself, they just deployed this HTTP for their communication. Let's consider this was the one of their headquarters and between their other branch offices. So they used SSL one version for themselves only. Okay, just for testing purpose. Okay, so then after that, again, there was so many bugs was there in that, and they just overcame with that. And then finally in 1996, okay, they came with SSL version 2, okay, which was for the publicly, and they have published it actually. Publicly, they published for, they published. Okay, overall STTP is one of the open standard protocol. Okay, so then they made it in SSL 2, sorry, SSL version 2. So this is also an open standard. So in 1996 they have developed, and they came with an SSL version 2. So after that, now again after 3 years, then in 1997, okay, they came with SSL version 3. Again, they just made some more changes into that. Okay, and after that, SSL version 3 is also known as TLS. This is also known as TLS. And after that, from the TLS again, there is the three versions we have in TLS. That is version 1.1, 1.1, 1.2, and then 1.3. So this is in 2018. So this is the latest and the last version of the TLS, which is in 2018. Okay, so this time we are using TLS. This is the latest version of SSL. Okay, still this is SSL, or you can say TLS, whatever, that doesn't matter. If someone is asking about the like SSL or TLS, the concept remains same there. Just this is the new name for the TLS, but stands still we call it as a SSL only. Okay, so this is the version of the TLS, and or you can say SSL is going on, which is 1.3 here. And who's managing this time? Right now, there is an organization, Netscape. They are only managing all this. Okay, and this is how exactly it's working. Okay, so this is how exactly it started. Okay, so SSL is the collection. So as I told, this is about the history of SSL. But as I told you, this is the collection of the protocol. So we have four protocols, because this is, as I told you, SSL is the pseudo protocols. This is what pseudo protocols, and usually we have a four protocols into that. Okay, so the first protocol is SSL, SSL handshake. Second, we have SSL change. Cipher suit, change cipher specific. I think, yeah, specific protocol. These are the name of the protocols, like your ESP and all. Okay, then we have SSL alert protocol, and after that we have SSL record protocol. Okay, so it's a combination of the four protocols. Like if I'll talk about an IPsec, we have the one, we have IKE, then second we have ESP, okay, and the third we have EH. So now this is the sort of protocols. Guys, kindly make a note and just let me know, then I'll continue with further. Okay, just kindly make a note of this. I'm just waiting. Once you would confirm, then I'll continue. Okay, just kindly make a note. Guys, I hope everyone is there. Right, yeah.
Yes, sir.
Done. What about other guys? All notes done?
Yes, sir.
Okay.
Yes, sir.
So now this is one kind of diagram we have in this. Okay, so just now you have to draw this one, and the like now we would work like as per this scenario. So this is, first of all, we have IP. We have TCP, SSL record protocol. This is okay. So first of all, we have here, this is all about IP protocol. This is about SSL record protocol. And this is about TCP protocol. This is I have SSL handshake. Then we have SSL change cipher specific. This is about change cipher specific. And then we have SSL alert. And then we have HTTP. This is how exactly it works. This is the suit of the protocol, guys. Okay, how exactly it would work. Okay, so everybody knows what exactly the IP protocol TCP. Okay, so SSL. Okay, so see, what is SSL protocol? This is SSL handshake protocol. So this is we use for authentication. The first concept, if I'll talk about here, this is all about what? SSL authentication. The main purpose of SSL handshake is SSL authentication. Change cipher specific means this is the meaning of pending state to full state. What is the meaning? During handshake only we will talk about this. SSL alert protocol, this is for the error messages. Any kind of error messages, okay, any kind of notification, okay, during the handshake or during the data transfer, then which protocol will be there? That time your SSL alert protocol. This is here, this is here. HTTP, you know, an overall record protocol we used for hashing and encryption. Hashing and encryption. Guys, kindly make a note. Yes, guys, kindly make a note of this sort of protocol. Yes, guys, all done. Once you're done, just let me know. Yes, done. Okay. Now, so after this, let's start with SSL handshake. So today I'll try to finish at least SSL handshake here. Okay, this is the concept. Okay, so as per the SSL handshake, we have two concepts here. In SSL, we have two concepts. So let's talk about SSL. Even three concepts we have SSL handshake. Okay, three kind of different kind of handshake we have. The first is server based authentication. Second, we have server and client based authentication. And third is connection resume here. Resumption. Okay, connection resumption. So these are the three ways we have. So first of all, I'm going to be start with this. Okay, this is I'm going to be start here. So now SSL handshake, which is as per the server based authentication. Okay, in this we are going to be use certificates. The certificate is all about digital certificate here. Okay, so which is kind of like you can say CA server CA concept. Okay, certificate authority concepts we are going to be adding to this. Or overall, you can say PKI concept I'm going to be using. Okay, so let's start. So let's consider this is one of the PC. Okay, who would be initiator of the connection. Okay, so this is PC here. After that, this is server, and let's consider from here you are trying to connect with this, and you are typing HTTPS, and that is server1.com. Okay, so first of all, I'm using HTTPS here. So first of all, there would be a TCP three-way handshake will be there. Okay, and after that, there would be SSL handshake. So now I'm going to be talking about SSL handshake. So once your TCP connection would be established, okay, in case if your TCP connection itself is not able to establish, and because of some reasons you are getting some error or something, so then obviously we won't be able to move towards the SSL. So first of all, TCP connection must be established successfully. Okay, after that only we can continue with the SSL handshake. So now after TCP three-way, then I'll move to the SSL, and the first is this time this is obviously my client, or you can say that this is kind of initiator, connection initiator, and this is about server kind of responder concept we have. So first message, okay, it would start from here, and the first message, the message name is client. Hello. In IPsec, guys, what is the name of IPsec first hello message, like first message? If I'll talk about in IPsec handshake, what is the name of the first message?
Initiator SPI.
Uh, initiator SPI. Okay, yes. Okay, that was the first message there, and usually we just call that haggle. Okay, first message is what? Haggle here. Initiator SPI, that is also one of the information into that. But here the message name is what? Client hello, and in this there is a different informations are there. What are the informations? The information is the first information is about SSL version. Second, we have this is SSL version here. Second information is this is SSL version. Then is about session ID. The third is random number. The fourth is cipher suit. Then the fifth is SNI. Okay, and the sixth, which we are not using these days. So one is compression method. So these are the six information which your client hello would carry from client to server, or you can say from initiator to responder. Okay, so what is the meaning of first thing, which is about SSL version 1? What is the meaning of that? So if I'll talk about SSL version, okay, so as you know, we have different versions over there. Okay, so it would send the which version, SSL version I'm supporting, or which I'm going to be use it out here. So let's consider it would use your TLS version 2 or recent version, which is TLS 3 here. So this is the information. Okay, because server would support all the SSL active SSL versions. Let's consider SSL version 3, which is TLS. Okay, then TLS version 1 and TLS version 2. Then we can say TLS version 3, because server has to support all the versions, because server doesn't have any idea, because as a server administrator, I'm not sure what kind of client would try to connect myself, okay, with my server or with myself from outside, okay, or might be that guy would be using SSL version 3 or TLS or whatever. So that is not an idea, okay. So that's the reason on the server we have to open the gates for all the versions, okay. So this is TLS version 3, first thing. Second, we have session ID. Second, we have session ID. Session ID is, there is a two possibility. The one possibility A is about it could be null, and the second possibility it could have some value into. It could have some value. If it's null, what is the meaning of null? Null means the session is new. Okay, the session is new. Okay, or you can say the device or the client is trying to, the client is trying to establish a new connection with server. It means what? This is the connection of the new server. But if I'll talk about in case if there is some value, so it means the session is not new. Okay. And now, and the client is trying to resume previous session. It's trying to resume what? Is trying to resume its previous session. Okay, so then there would be some value in this. Well, let's consider there would be some value into that. Okay, and in case if it's a new, so then it would be totally null, as you know. Null means it's 000. There won't be any value. So the question is how this value is going to be helped. So server always keeps some, obviously on the server side, it would keep a track of all the connections. Okay, so like terminated connection, okay, ongoing connections and all. So let's consider this is one of the database. Okay, and here the server would keep the data, or you can say this, these are the all the active sessions here. Okay, I hope, see, I hope you remember, like, if I'll talk about in Facebook, Instagram, WhatsApp, like, on laptop, if I talk about my Instagram is already logged in. Last time when I have logged in, I don't remember even. Same about the LinkedIn, same about the Twitter, same about the Gmail account, same about with the Yahoo and all. Okay, on the daily basis, and every time we don't log in, like in net banking. If you talk about net banking and all, okay, so every time we have to log in here. Okay, it's not like that in internet banking today you have logged in, and now after 5 days also the same page would be logged in only. It will keep logged in. No, that would be automatically log out. Okay, so that is with the help of the session layer. Okay, but that concept is known as null session and all. So, but overall in the context of SSL, that connection has been terminated. But right now I'm talking about those sessions which you have logged in long back and still it's there. So how the LinkedIn and active LinkedIn and Facebook and Instagram server would keep in their database. So let's consider first time when it's, let's consider this is the first time you're trying to connect with this. So your ID, null ID, sorry, session ID would be null. Let's consider this is my client message and this is client hello. And this is my, in this, the session ID would be null. This is at time t0. This is I'm talking about time t0 here. So this is null ID 0. So session ID server is the only device, and server is the only device here who would create the session ID. And let's consider it would create one session ID, and session ID number is 1, 2, 3, 4, 5. Okay, along with that, it would keep its all the information. This is session ID. After that, next time it would send the reply now ki, hey, your session ID is this much. This is your session ID. After that, there would be second message and it would says, okay, now this is your session ID. What is that? 1, 2, 3, 4, 5. And let's consider right now, all the communication, everything is done, everything is fine. Next time, after 2 hours or after 3 hours, now you have closed, you have not signed out, you have not terminated the connection. You just closed your Google Chrome or something, or might be you just shut down your laptop. Next time, again, if you would try to open your Facebook and Instagram, so what happened? Instead of sending SSL null ID 0, so next time it would send ID as a session ID as a what? 1, 2, 3, 4, 5. Okay, and once the server would receive the same ID, okay, then it would check it. Key, okay, because server is checking key what is the session ID. If session ID is null, so that means that is a new connection. But in session ID, if there is some value, so it means the session is not new. Okay, so it means it's trying to resume its previous session. So that time collection means client is trying to resume the session. So it means which concert would be active? This concert would be active. Okay, then it would check in its database. Do I have any connection ID like 1, 2, 3, 4, 5? If it's there, so then it would work accordingly. Okay, because based on session ID, it has to use its cipher suite, sorry. What is a cipher suite? Cipher suite is a collection of encryption algorithm, hashing algorithm, right? Because if there is a two different pieces, so might be here they are using for encryption 3-, and for encryption here it's using AES. So these are the negotiation process. Okay, like client and server has to negotiate, like we discussed in IPsec. So further we have further messages. Overall in SSL we have 10 messages there in server based authentication. So in case if this device is trying to resume the session, means this device has already all the details key on which parameters we have negotiated, and is just trying to check with the server. If server also has the same information, so now server would resume its connection. Okay, and next time which handshake will be there? Connection resumption over here, because here we have only 6 messages too. So that would be faster and no need to negotiate on the cipher suites again. Okay, cipher suite means the collection of hashing algorithm, encryption algorithm, then they would exchange keys and all. So that is not needed. Okay, so the session ID has a 2 possibilities. If session ID is null, it means its session is new, so it's a new connection. And if it has a some value, so it means it's trying to like resume its one of the previous session. Guys, is this clear? What is the meaning of session ID?
Yes, sir.
Anyone, any doubt, any questions? Only one girl has replied. What about other? Guys, are you there or not?
Sir, understood, sir.
Yeah, just kindly acknowledge, and I'm waiting for the acknowledgement. Okay. So this is the concept we have. So next, after this, so this is first concept is here, SSL version. Second is session ID. Third is random number. Random number size is 32 bytes. If I talk about random number, so that is 32 bytes. Usually random numbers we use in the future, like in the upcoming handshake, we would use it. So this is we use to generate pre-master. That is about to generate the pre-master key here. What is the pre-master key? In the upcoming message we will talk about, but let's now right now I'll talk about exactly what is random number. Random number, the size is 32 bytes. it is divided into two ways. Okay, one is 4 byte and 28 bytes, sir. This is for 4 bytes. This is all about timestamp, and second is remaining is 28 bytes, which is just a random. Okay, so this is it's going to be used into the upcoming pre-master key. That time we will use this one. So this is just a random number. Random number could be anything. If you would ask Amit what exactly the random number, its name itself is saying random. So random number could be anything. Okay, but what is the size of this random number? 28 bytes. And what is this 4 byte? This is all about the timestamp here. What exactly the time? So it would check here time zone. Okay, and then all about the times. Okay, so this is the concept about random number. Next we have cipher suit. Okay, what is cipher suit? Cipher suit is the collection of what? This is your cipher suit is the collection of algorithms. Okay, algos means in the context of encryption and hashing. Okay, like which I'm going to be use AES, or I'm going to be use here dash, or am I going to be use here MD5? Okay, what exactly the concept I'm going to be use it out here. So cipher suit is the collection of the. This is about the collection of the algorithms. Okay. Next we have SNI, server name identification. So this is actually the part of one of the extension. Extensions, this is extension is what? This is some kind of extra information. Okay. Like in TCP, we have options. Guys, are you able to relate it with the TCP options? Yes, guys. I hope everybody knows TCP options, right? Guys, do you remember or not? Guys, if you're sleeping, no problem. We can have the session later. TCP option is a kind of extra information, okay, which your TCP carry from the one device to another device, okay, from one node to another node. Okay, so now what is extension? Extension is a kind of extra information. Like in TCP, we have a TCP option like MSS and selective acknowledgement kind of stuff we have. So extension is kind of extra information, okay, which is beyond your like SSL header. So actually it has in the extensions, if you would ask me, so there is a 10 to 12 different extensions are there. Total how many extensions are there? 10 to 12. Okay, these are the total, if you would ask me number of extensions, so it's between 10 to 12. Okay, but SNI is one of them. SNI is one of them. So this means what? Server name indication, identifications, I think so. Okay. So what exactly this mean? So see, sometime what happened, let's consider on a single server. This is the one of my single server here. And on a single server, I'm hosting 3 or 4 websites. Okay. This is one client here. Okay. And it's connected with the server. And its server IP, this is the server.com. Okay. And here it's hosting multiple sites. Okay, 2-3 sites let's consider. So this is about something abc.com. So this is cbc, let's consider cbc.com, and this is about, let's consider def. or let's consider cas.com. Okay. So overall, this server is about server.abc.com, server.cbc.com. Okay, this kind of information will be there. Okay, so there, this is kind of like we have URL server.abc.com. Then we have server.cbc.com, and then we have server.cas.com here. Okay, this information. So now from here, this guy would be, let's consider want to establish a connection, SSL connection with the CBC. So what happened? Now server dot, it would type cbc.com here. So the problem is when the request would come on this server, the server has to identify the CBC is exactly this is for what. Okay, so even we can use here the common name also, we can use a separate name also. So SNI is one of the extra information which we have. Instead of using an IP address and all, so we would have their SNI information. SNI means in the SNI server name identification means your actual website name will be there, the server name will be there. So in this one, it would be at cbc.com here. So that would be what? Server.cbc. So SNI would carry the name of the websites, the name of the server. Okay. So this is about server name identification here. Okay. So this portal, this concept would carry your server name from one device to another device, or you can say from client to the server. Okay, so then it would be easy for the server to identify okay, I'm getting one client hello. Okay, because let's consider this is for the client hello message is there. In the client hello, first of all, there would be SSL version, then there would be random number. After that, there would be which one? Let's consider cipher suit, session ID, okay, other informations. Now the concept is the server is saying, hey, I'm hosting 3 websites exactly. So is this SSL for the which websites? Okay, for the which server, which device exactly? Okay, so for that, what would be there would be one concept about SNI. SNI means SNI, it would define okay, server.cbc.com, and then server would be happy. Okay, now I just got to know this SSL is for which one? This SSL is for this particular interface. Okay, out of these 3. Okay, so this is for what? This is for this particular. So this is the way how exactly SNI would help us. Okay, so this concept is known as your SNI. So this is one of the extension. This is one of the extension we have. Then we have compression method. It's absolute. We don't use right now these days. Earlier we were using during the HTTP version 1, version 2, okay, and version 3 we have used, but in TLS we won't use it. So this is what this is kind of compression method. Compression means like I hope you know guys, zip file and all. Okay, zip file is what? If you have a file of 10 Gbps, so it would compress into 1 GB and then it would share. So earlier, like during the HTTP version 1 and HTTPS, like during the earlier version of SSL. Okay, as if I'll talk about SSL version 1, during that time, SSL version 1, 2, 3. So there was a concept about compression. So whenever they would carry the information from one device to another device, so it used to compress inside the header itself. So that was a concept. But right now it's obsolete. We won't use it. So just I have mentioned it. Okay, but these days we don't use it here. So this is just one of the internal compression method of the SSL. Okay, in the early days we were using it, but this time with the TLS and all, we don't use compression method here. But still, once we would start capturing the packets, we will be able to see, okay, compression method into the header. So that's the reason I have mentioned it here. Okay, otherwise this is no use of the compression method. So the first 5 things are very important here for us. The first thing is SSL version. Which version of SSL are you using it? Session ID, 2 possibility null or value. If it's null, so it means session is new. And if it has some value, so it means we are trying to resume the previous session. Then we have a random number, which we are going to be using in the upcoming classes, like not upcoming classes, sorry, in the upcoming messages. Okay, so it's divided into 4 byte and 28 byte. 4 byte is about timestamp, 28 is about just a random number. Cipher suit is a combination of which exactly algorithms combinations and we have, like in IPsec. In IPsec, in the first message in the proposal, we used to send what? Haggle. And I hope you remember we have configured multiple haggles there, multiple ISA-CAM policies we have configured. Let's consider on the site one, if you have configured 10 ISA-CAM policies, so in the first message, it would send all the proposals. So same here, the client would share it's all the supported, like you can say supported cipher suit here. I do support this combination, this combination, this combination, this combination. Okay. I do support AES and MD5. I do support dash with SHA. Okay. I do support AES with SHA then. So these are the combinations into that. So this combination is known as cipher suit here in the term of SSL. Okay. So this is by default, these things are present always in the browsers. We don't have to configure anything over here. So if I'll talk about in the browsers and all, everything would be pre-configured. We don't have to worry about all this. And usually there is a like 17 to 18 cipher suits we have in the Google Chrome, which is the by default present into that. Okay. So then we have SNI, server name in identification, which is one of the extension, okay, which would carry and which would keep the information of the server, just like Amazon.com, Flipkart.com, okay, Twitter.com. So whatever kind of stuff you're using it, whatever you're browsing it, the server name, okay, that server name information will be present in your this field, which is SNI here. Okay, so this is guys all about first message, which is client hello from client side to server side. Okay, so this is the information from here. So any doubt, any questions into this? Yes, guys. Anyone, any doubt, any questions? All clear?
Yes, sir.
Second message we have server hello. This is the same like a your IPsec. In IPsec we have the first message is from the client side, then another initiator side, another is from the responder. Responder is what? Selected concepts here. So then same kind of information we have here. Client hello is kind of proposal. Just I can support or I do support these kind of things over here. So do you support it or not? Okay. So that kind of stuff. So this is okay. So from here, let's consider earlier the client has shared the multiple options. Okay, I do support this kind of SSL version, this one. And finally, this device has selected. Okay, let's work out on TLS 1.3. Session ID in the first message, if it was null, so then it would create and that session ID here. So this is session ID which is created by the server. Random number. If I'll talk about this random number, okay. So in the client, this concept is known as here client random number. Client random number. Okay, this is of 32 byte. And now this side, it would send again its own random number, and this is known as server random number. Okay, random number could be anything, and it's the size of the 32 byte here. This is all about the selected cipher suit. Okay, because client has already sent the proposal of the 10 cipher suits. Okay, so it would choose one, and this is the selected cipher suit. So this is SNI. There won't be. This is the same name. Let's consider Amazon.com compression method, kind of null, and we don't. Okay, so this is the information from where side. This is from the server hello. So first is client hello, and client hello is kind of all the proposals. Okay, and server hello is just a reply for those purposes. So this is known as server hello. Yes, guys, I hope this is clear.
Yes,
This
sir.
is second message.
Yes, sir.
The third message is along with this. Now, it would send, the second step is, this is server certificate. What is that? Server certificate. Okay, because here server would try to authenticate himself. So this is a server certificate here. And guys, this is considered, this is server certificate. As for example, this is server certificate here. Okay, this is one of the, you can say this is DGCRT, digital certificate. Okay, guys, already encrypted. Guys, this is already encrypted with the help of the which key, guys? This certificate is already encrypted. How and with the help of the which key?
Private.
Private.
Yes, anyone? Okay, Benita, you only explain.
So it uses private key for encryption.
Which private key? Whose private key?
That the certificate produces a private key.
Certificate authority. That we call what? Certificate authority.
Certificate.
Okay, and how my client is going to be decrypt that?
It uses its public key, which
And
is
how?
stored in a. It will be
Which is
stored in.
which would be stored in the browsers. Okay, with the name of as a root certificate, trusted root certificate. Okay, because trusted root certificate, this certificate is also known as identity certificate here. That is our identity certificate. Okay, and if I'll talk about the public key, so the public key is known as, that is root. Okay, this is server certificate. After that, you know, client, how client would be decrypt and all that process we already discussed, right? Next is we have, this is server public. Let's consider this is Amazon server. So this is Amazon server public. This is not the DGCRT. This is the public key of the server. Okay, this is considered Amazon. So this is Amazon server key. And after that, one more message from here that is known as server hello done. Okay, so actually here I have mentioned it as a 3 messages, but all these 3 information would be present in a single message itself. Okay, which is digital certificate, server public key, and server hello done. Okay, so this is the 3 informations, but we have to consider it as a 4 different one. Okay, 3 different one. Okay, but actually all these information would be carried into single message itself. Okay, so server hello done means finally kind of acknowledgement ki yes, I'm done now. Okay, just I'm done here. Okay, so this is the concept about this. Yes, guys, any doubt, any questions here? Up to here, we are done. Okay, so we have exchanged client hello. First, we started with the client hello here. Okay, after that, after client hello, we have server hello. After server hello, this is the same information which like client carried from in the client message, but this is kind of the selected one because client hello is kind of proposal. After that, we have server certificate, which is about authentication. Server is trying to authenticate himself. After that, we have server public key that we will use in the future in the upcoming messages. Okay, and then we have server hello done. Yes, I have exchanged all the information. Now I'm done. So now this is the, now let's move to the next phase, okay, of the handshake. Guys, up to here, is there anyone who has any doubt, any questions? If you have any doubt or questions, kindly ask me now only. All clear?
Yes, sir.
Okay. Next concept we have now after this into this, now again we have to go back to the client side. Okay, this is from the client side. So client would share, okay, it would send some keys concept here. Okay, so client would now, it would, you can see here, I'll mention. Client would share pre-master key. What it would share? It would share the pre-master key. The question is, what is pre-master key and how this client would generate the pre-master key? Guys, do you remember? See, I'll highlight some points. See, from the client side, we have shared its random number. This is a client random number. Okay, so here we have, let's consider, for example, let's consider my client random number is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. This is a client random number. So the client, obviously, this is a client random number. So client is like holding its own random number here. But we have shared with the server also. So means it means on the server side, this is the client random number. Client random number. But on the another side also, we have same random number or not, guys? Because I have already shared it with whom? With the another side. Yes, guys. Agree with this concept? Okay, clear? Second, now this side from here, the server also it has shared its random number. That is, let's consider 0987654321. This is what? Server random number. Okay. So this server also has shared with the client. So this side also we have random number. This is server random. So this combination we have on the both the sides. Agree or not? Yes, guys. This term is clear. Everyone? All clear, right? Yeah. Benita is clear? Because only Santosh is
Sir.
replying. Yeah.
Yes, sir.
Pawan and all clear? Okay.
Yes, sir. Yes.
Okay. After that, we have a cipher suit here. Okay. We have selected cipher suit, obviously. Same, we have selected cipher suit on this. Right? Okay. After this, okay, what happened now? So this time, okay, it would, on top of this, client and server, both would perform some of its internal algorithms and mathematical formulas, and with the help of that, they would calculate pre-master. So now, note on the another side, this client only, because here now need to generate pre-master key. Need to generate pre-master key here, because as I have mentioned in this, the client would share its pre-master key. Okay, so what is mean? It means the client, okay, so need to generate the client pre-master key, and only client can generate the pre-master key. Okay, server doesn't have the capability or permission to generate the pre-master key. Or you can say here, I'll mention the server cannot generate. Are you getting my this point, guys? Is this clear? What I have mentioned? The client can generate, but server cannot generate pre-master key. So it would perform some mathematical, it would use some of the internal algos or some mathematical formulas, okay, to, to calculate to find out what? It's pre-master key. And let's consider finally, after this calculation and all, so it has generated the pre-master key over. Consider this is the pre-master key. Not in this text. So let's consider. This is, for example, consider this is pre-master key. Okay, it has calculated and finally it's found out this is pre-master key. Guys, kindly listen it very carefully. Up to here, it's clear or not? One by one, I'll ask you because 4-5 steps we have here. That's the reason again and again I'm asking. Is this clear up to here?
Yes, sir.
Other
Yes, sir.
students? Now,
Yes, sir.
what is the client has to share this pre-master key with the whom to this one. So I cannot share it in the clear text here because this is the what? This key is into which text here? This is into clear text right now. Okay, so I cannot share in the clear text here. So what I'll do, guys, do you remember earlier here, the server has shared its public key. Do you remember, guys? Server has shared its public key. So consider it on the server side, we have public key. So this is server public key. And that public key is considered ABC. And now server private key, which is about BCT. Yes, guys, this is clear. And let's consider this is that server public key here. Consider it. Okay, and where and when we have exchanged, when the client has received it, this is that server public key. Okay, guys, is this clear? Now, what happened? Key, this client would encrypt this pre-master key. Okay, that is what, 1 second. Now, so see, this side now, what happened? The client would encrypt it with the help of what? Public key of encrypted with public key of. So, guys, is this clear or not? Client has encrypted this pre-master key with the help of the server public key, which we have already received and previously. Okay, and now it would share this pre-master key with the server. Clear? So this is now encrypted with server, and client would share pre-master key. Okay, so now on the this side we have pre-master key. Server would decrypt it. Now server would decrypt this pre-master key with server private key. Okay, and what is that server private key? This is server private key. Okay, and after that it would be decrypted. Yes, guys, up to here it's clear.
Yes, sir.
Okay,
Sir, I
so on
have a
the
doubt.
both, yes, please.
For the very first time, if we send uh, like a pre-master key to the server, will
Mhm.
it will be encrypted to the, how it will be going to encrypt, sir? Because we don't have any like server pre-master key, right?
Sorry, I didn't get it.
For the very first time, if we sending the like pre-master key of the client to the server,
Hmm.
we will be not having the server pre-master key, right, sir?
For server pre-master key, I
To
do not
encrypt.
want it because only who can uh generate the pre-master key? Only client. Server pre-master key is not needed. Okay, because here it's encrypting with the help of the public server public key. Okay, and
Okay.
where do we have server public key? We have already exchanged it. That is where this is the we have server public. From here we have received the server public.
Okay, sir.
Okay, because in the upper phase, server already shared its public key and the client is already having. So with the help of that public key, it would encrypt it and would share it. And now because this pre-master key is encrypted with the help of public key of server. So in this world now on this earth, only who can decrypt it? Only server can decrypt with the help of private key here. So this is we have taken. Clear or not? So we have a same pre-master key on the both the sides. Yes, guys, agree or not? Right?
Yes,
We
sir.
have same
Yes,
pre-master.
sir.
Now it would add into this. What happened here? Into this pre-master key, okay, on the both the sides, they would add server public key. Sorry, not server public key. Yeah, this is master now, correct. Server public key. Okay, and along with that, they would use the same random concept here, random number, but that is not again. So this is just a server public key. After that, on both the sides, the client and server would perform one PRF on that. PRF, pseudo random function. This is what? One of the pseudo random function on both the sides. Okay. Not right, not now. Sorry, not now, not now. So it would now on the both the sides, this is the combination and this is the combination. And after that, they would generate one more key with the combination of this, that is master key. What is that? Master key. And let's consider that master key is, for example, this is the master key. The same, we have a master key on this. Because the master key will remain same, guys, or not? Tell me. Why it will be remain same? because we have same random, same pre-master key on the both the sides. We have same server public key on the both the sides. They would perform some internal algorithms, or with the help of internal algorithms, they would generate the master key. And now we have a common and the same master key on the both the sides. Yes, guys, is this clear?
Yes, sir.
Yes, sir.
After that, the last concept. On top of this pre-master key, now both the sides would perform one PRF function, one of the pseudo random function here, and with the help of that, on the both the sides, on the both the sides here, okay, they would generate two separate keys here. One is for integrity, okay, and one for encryption. Integrity keys and encryption keys, you can say. Clear or not? Okay, that will remain same or not. So let's consider it is the same random function, same doing it on the it's doing it on the same thing. Let's consider here integrity key is something this, okay, and this would be my encryption keys here. Yes, any doubt, any questions up to here? Yes, guys, any doubt, any questions, anyone? All clear?
Yes, sir.
Okay. Now, after that, the client would share its first encrypted message. It would send its first encrypted message. Okay, now, hey, this is kind of testing. Okay, or you can say it would send, hey, oh, 1 second. Hey, this is my first encrypted and hashed message for testing. Okay, this message is known as, okay, change cipher. Okay, that is known as change cipher specific protocol. Who would carry this information? Change cipher specific protocol. Okay, and after this is the last message from the client side that is finished. Okay, now I'm done. Okay, now I'm done. Okay, so this means what change? Hey, this is my first encrypted and hashed message for the testing purpose. Okay, and now let's switch to a secure communication environment. Okay, let's switch to the secure communication. So technically this concept is known as pending state to full state. Okay, so everything will remain same. So this is now from another side. This is again same chain cipher specific protocol. This is the only message. This is from the server side now. Okay, this is the message here, and overall this is the same information would be from this. Okay, the same from here, and this is also pending state to. And the last is yes, finished. Okay, I'm done. This one. So total overall, how many messages? Let's count it. First message from the client, hello. Okay. Then we have second is server hello, then digital certificate 2, 3, 4, 5. This is 5 here. This is 6, pre-master key. Okay. Then we have 7, 8, 9, and 10. Total how many messages? 10 messages. Okay. So this is the concept about this. So we have Hanu, how many messages do we have here? We have 10 messages. And second, we have 12 messages. Second concept also I'll explain now. It will just take a 2 minutes for me. Okay, that's it. So just tell me first thing, the first concept, the server-based authentication. Now we are done. So is this clear or not? Any doubt, any questions at any point? So you can ask me. Anyone, guys, any doubt, any questions?
Sir?
Yes, please.
I just have one doubt, sir.
Yeah,
Let's
please.
say I'm opening a Facebook website. So in SSL process, so how the hashing and encryption will be decided, sir?
With the help of the cipher suits, which you have we have discussed in the first client hello. Just check your notes. Okay. So one concept is there, that is cipher suit. So what is the cipher suit? The combination of encryption and hashing algorithm.
We have different varieties, no, sir. Which one it will going to select?
That depends on the server. They have some priority concept and all.
But you said server will be, capable of serving all the
Yes,
varieties.
let's consider you are capable doing of 10 things at the same time, but
Yes, sir.
you have to decide ki which one you will do first, right? Let's consider
Yes.
at 8 a.m. there is a 2 batches. One is VPN going on and one more batch is going on. So Networker SOM has capability to run multiple batches, correct? But as a
Yes.
client, are you able to do all the message like batches at the same time? No, correct? So,
Yes.
okay, so that time the networker SOM would decide, okay, you just do one thing, you just start with the first VPN. If you are in security, you are doing ICE badge also. So you are just asking, right? So same client is sending in a proposal like a IPsec. In IPsec also, we used to send how many proposal in the first message? Up, we have configured 4, 5, right?
Yes.
Okay. So how the server has decided? So they have some algorithm based on priority or something. Okay. They would decide, okay, out of this 10 proposal, I'll choose second one, or I'll choose the first one, or I'll choose the last one. Okay. And accordingly, they would work on.
But as far as me, so I have just typed facebook.com. So in background, it will all happen. No, I just wanted to
Yes.
know which one it will going to choose, sir.
So this is, you are again at the same questions. You are just try to understand what I'm saying. Kid SSL happens automatically. Everything is pre-configured in the Google Chrome. You don't have to do anything, right? Because this is the browser way. So in the browser, already more than 10 proposals are predefined. In IPsec, we
Okay.
used to define ISACamp and all, right? ISACamp encryption, hashing group, algorithms, right? But all these things are predefined in algorithm into browsers. Okay, more than 10 proposals are there. So when you are typing facebook.com, so then my device or my Google Chrome is sending all those 10 proposals to the Facebook. And then Facebook server would choose one out of the 10.
Yes, sir, got it. Just like root certificate, this will also be pre-configured on browser.
yes, this is a pre-configured only, right? Let's consider you are a non-technical person. Okay, so do you know exactly how SSL is working? No, and you don't have to worry about that. Okay, well, let's consider tomorrow onwards and Google and Facebook, they would decided, okay, no, we are just removing all the pre-configured everything about SSL and all. There won't be any cipher suit and all. So do you think a non-technical person will be able to configure all those things? Definitely not, right?
Yes, sir.
Okay, if you, let's consider, if I'll ask you, okay, configure IPsec, you can configure it. But if I'll ask this question to my HR, so do you think she will be able to do that? Definitely not. Okay, so browsers and all, these are the kind of open browsers here. This is not any specific one, okay, which is available for each and every candidate here for the technical and non-technical. So all these things are pre-configured behind that.
Okay, sir.
Okay, right. So even before joining the VPN classes and all, I'm not sure how many of you were aware about SSL, HTTPS. But whenever we are using HTTPS, we are using by default one VPN. Okay, let's consider. I'll just open my LinkedIn. I open LinkedIn here. Okay, so now automatically VPN has been established, but we don't have any idea. As a non-technical person, I don't know what exactly is happening, but I know this is secure and this is happening. It's fine. Correct. But how backend is working out? Okay, so that is that backend concept. This is the backend concept. Okay.
Okay.
Yes, guys, all clear? Everyone? Any doubt? Any questions? Anyone in this?
Sir, one more doubt, sir.
Yes, please.
In session ID, if in case we are trying to re-establish the old session, how long that server will hold
That
that?
depends on server to servers, like Facebook and all. They have their own. Say, let's consider after 5 days. Also, if you're trying to log in into your Facebook, still your session would be active. Okay, but if I'll talk about in banking websites and all, they have a less time. So that is depend host to host, who's hosting the websites and the server. This is not dependent on us. That is based on host. Host means the servers. Okay, so Meta is the company who will be responsible for that, and they have their own criteria for this. Let's consider if you are going to be host a new server. Okay, so when you will host your device, so then you would have an option for how long you want to have, like how long you can keep idle sessions into your database for a 1 day, 2 day, 3 days, 10 days, 20 days. So that you have to define yourself.
Okay, sir.
Okay, that is server to server. Now, so even as a host only, let's consider, guys, if I talk about a Facebook and Instagram, okay, LinkedIn and all. By default, on these websites, on these server, they have mentioned server-based authentication only. We will only authenticate ourselves. But let's consider for a moment, just mention that they have decided that server and client authentication concept means client also has to authenticate. So let's consider, okay, I'm just a normal user, okay, and a client is asking, like Facebook, I'm trying to connect with the Facebook, and the Facebook is asking, okay, I have authenticated myself, now you have to also authenticate. So obviously, guys, the client also has to buy one certificate. The client has to buy a certificate over it. Yes or no? Let's consider for this one certificate, okay. Now it's charged, it's like on the cost for that is 10K for a year. So guys, do you think the people, okay, who's using internet in the small villages and at the remote locations, who's totally non-technical and all, do you think they would be able to access Facebook then? There's a two concept. One is they are totally non-technical, they won't be able to understand all this concept. And second thing, the money, okay, that is also 10K. So obviously no one is going to be buy those kind of concepts. Obviously then billion of users would be cut down from the Facebook, sir. Agree or not?
Yes, sir.
But let's consider Yeah. Any doubt?
No, sir.
Yeah, but now let's consider I'm working in network. Let's consider you're working in Cisco's and all, and they have some sensitive data or on their servers and all, and they have 100 of employees. So what they want key out of 100, they just want to give the access just to specific 10 users only, not to the other guys. So on that time, they just whatever the server they have, so they just want to host and they just want to apply server and client based authentication the both the ways. Okay, so that time what we have to do it on the server, we will enable server and client authentication, and then on the client side, so then we need a certificate. The certificate can be from the private server and that can be from the GoDaddy and DGCRT. So it means overall concept is clients also need a certificate to authenticate himself towards server whenever the client would access the server there. Okay, so then what happened there? Okay, first the guys from the client side. What is the first message? Tell me. Everyone now, guys, now so you remember, right? You know. What is the first message? From the client side, first message,
Hello message.
Client hello.
client hello, not hello, client hello. The second is from another side,
Server hello.
server hello. The next is server certificate,
Server certificate.
public key, server hello done. So this is now server certificate. Okay. So now what happened? You know, after this, server would send one more message. Okay, or this is if you have enabled here server and client authentication. If you have enabled server and client authentication, both the concepts, the second concept, so then it would, this is the request for this is then server public key, okay, and after that note this server hello done. No, after that what happened here, additionally it would send now, this device would send client certificate. This is what, okay, and now here server hello. Is this clear, guys, now? Okay, so total how many messages this time? 1, 2, 3, 4, 5, 6, and 7. Where are the, what are the new messages here? Request for this and this. So these two one, which I'll circle it out, this message and this message. These are the two new messages. Okay, and after that, what we have? The same concept, same after that. Here, from here now, I'll just mention it on this side. Pre-master key, encrypted pre-master key from the client side, the same method, okay? After that, chain cipher specific, finished, then chain cipher specific, and finished from the another side. So this is here, pre-master key. This is change cipher specific. This is finished change cipher specific, and this is, so total messages 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So total how many messages? 10 messages. Is this clear or not? Yes, guys. Yes, guys, anyone, any doubt, any questions, anyone? All clear? Any doubt, anyone in this batch? All clear? That's it. So I'm done for the day. Okay. So this is all about two things. The third one, more is pending. That is clear connection assumption that we will talk about, that we will discuss in the upcoming class here, not today. Okay. So 1 second. I was searching for a book actually that is the best book for SSL. That is bulletproof something is there. One bulletproof book is there. Okay. That is best for this.
Next month till which date it will go, this VPN batch?
Let's see actually, because most probably I'll finish it up to 16. That is my plan. Okay. Oh, today's Thursday. Shit. I thought tomorrow we have class. So 2 more weeks we have. I think here I'll try to finish your SSL in a 1 day. I don't think so that's possible. This is here. 2 days. Then after that, 2 days for the get VPN. And because 16th is the last we have date for the dispatch. So still we have 3 more weeks. That is more than sufficient. 3 days. This is 3. That is more than sufficient.
In this split tunnel also we can cover, or it's different?
No, split tunnel is not there. That is absolute because as per the Cisco syllabus, that is already absolute. Okay, so 1 second. Review craft material. This is there is a one bulletproof book is there. Yes. Just guess 1 second. Let me download this book. So this is the book, guys, and this is I'll suggest to go through this. And this the as from my side, this is the best book for SSL. Otherwise, it's your call. It's person to person. Okay. So this is the VPN which batch October 23. Here only I'll upload this, or otherwise I'll upload into document itself. Bulletproof. One of the best book actually I have seen in SSL. Okay. So this is, you can get into the exchange and all. So you can get into. Okay. So this is all about the protocols and all. So these are the handshake keys. Okay. Full handshake with server authentication, client hello, then server hello certificate, server key exchange, server hello done. Okay. So this is explanation about all these things. These are the cipher suit, guys. This is the combination. These are the cipher suits here. This one. That 10 cipher suit what I was talking about. Okay, version, random number. Does a random number is defined on the timestamp. Then basic random bytes we have. Session ID is what? Empty because connection is new. Then we have cipher suit. Compression method is null these days because this is not there. And these are we have different extensions we have. But in this extension, this is the first one is server name here. Okay, so this is one of the website name. This is the first concept. Then we have during both client and server based authentication. So this is the one certificate and certificate request for this. And this is certificate on this. Okay. So this is one here. Session. This is session resumption. Tomorrow we'll talk about this. Okay. Client hello and all. This is here. So this is in the proper ways they have mentioned it here. Okay. So this is the one of the best book for SSL. So in case if you want to do mastery in this one, because SSL, you know, this is SSL and IPsec, two are the most important protocols in the VPN. So this is for SSL, this is the best book here. Okay. So this is that's it. Okay, you can go through this. Already uploaded in your drive. Okay. So I'm done for the day. Guys, if you have any questions, if you have any questions, you can just ask me. How many of you are doing AWS with me, guys? Currently, how many of you are doing AWS? Okay, because today we do not have any AWS batch because of some reason my this AWS account got suspended, and that would be open today actually in the night, because yesterday night actually got suspended. Though not suspended, I think that is suspended just for the 24 hours. Okay, so today it's going to be open at 7 o'clock. Okay, so what is the concept? Today we don't have any session of AWS, but tomorrow I'll take one session. Okay, of AWS. Tomorrow even I have holiday, but still in the morning 8 to 10 I'll take AWS session. Okay. Because today's session I'll compensate it tomorrow. Okay. So tomorrow we have AWS session in morning, not at 11 o'clock. Are you getting, guys? Is this clear?
Yes, sir.
Yes.
Yeah. So instead of today's, the class would be tomorrow morning 8 o'clock. Okay. That's it. Okay. Okay, guys. Then bye-bye. Take care. See you tomorrow. Okay. Thank you.